Hello guys. So today we'll be discussing differentiation of uh, hyperbolic functions. So I won't go deep into them. I'll just revise with you the formulas that we used when we differentiate hyperbolic functions, as well as to let you know how to differentiate them from trig functions, because they are similar a bit. So let's start with the formulas. So if we are differentiating hyperbolic sine of x, which is hyperbolic sine of f of x, then this is going to be f prime of x, because we should always differentiate the argument. And then so whenever we differentiate hyperbolic sine of x, this is just going to be hyperbolic cos of f of x, just like that. And then when we differentiate hyperbolic cos of f of x, this is going to be f prime of x multiplied by hyperbolic sine of f of x. Hyperbolic sine of f of x. Also, when we differentiate hyperbolic tan of f of x, this is going to be f prime of x multiplied by hyperbolic sec squared of f of x, just like that. So these are not the only ones. The three remaining ones are going to be dx of hyperbolic cosec of f of x, which will be equals to negative f prime of x hyperbolic cosec of f of x multiplied by hyperbolic cot of f of x, just like that. And then also another one is going to be the derivative of hyperbolic sec of x, hyperbolic sec of f of x, which will be negative f prime of x multiplied by hyperbolic tan of f of x multiplied by hyperbolic tan of f of x, just like that. And then the last one, dx of hyperbolic cot of f of x. This is going to be negative f prime of x multiplied by cosec squared of f of x. F of x would be any argument, so I'm using it so that you can understand that it's replacing any argument that will be given to you in those different types of equations that we'll be solving. So yeah, those are the formulas, guys. So one thing to notice is that when we differentiate the hyperbolic cos, it does not become negative. I know that in trig function, when we differentiate cos, it becomes negative, but it's different here. So that's one more thing to note, as well as when we differentiate sec, it becomes negative. Meanwhile, in trig function, it whenever we differentiate sec, it becomes positive. I didn't finish this, of course. When we differentiate sec, this is negative f prime of x hyperbolic tan of f of x sec of hyperbolic sec of f of x, of course. Yeah, so that's one more thing to note there. Yes, that was just a minor mistake. Thank you for understanding. Okay, now on our first question there under activity 7, we will have to find dy dx if y equals to hyperbolic root of x. So this is just going to be dy dx, which equals to the derivative of hyperbolic cos. We just discussed it, that it's going to be hyperbolic sine of root x. Then of course we shouldn't forget to multiply by the derivative of the argument, which is just going to be 1 over 2 root of x. And then we can decide to write it nicely in a way that it will look like hyperbolic sine of root x divided by 2 root of x. And then yeah, that should be your answer. So guys, you can pause these videos so that you can work out on the problems before you can check the meme. And then that's a very good way of learning these things, learning how to apply these things. Okay, we've got another one here, which is cos of that. So when we see this is just the identities of hyperbolic functions, whereby hyperbolic cos squared of 3x minus hyperbolic sine squared of 3x is equals to 1. So we can just apply the identities and then it becomes simple like that. So when we differentiate it now, so dy dx will be the derivative of a constant, 1 will be 0. And then yeah, that's going to be your answer. And then now we are going to have hyperbolic tan of 1 minus that. So now we're just differentiating hyperbolic tan with regards to that argument. So maybe I can just rewrite this first so that we will all understand what's happening. So this is 1 minus x to the power minus 1, like that. So when we now differentiate it, dy dx will then be the derivative of hyperbolic tan is just hyperbolic sec squared of that argument that we're given, which was 1 minus 1 over x. Then we shouldn't forget to multiply by the derivative of the argument, which is just going to be what? Negative, the derivative of 1 is 0, and then negative by that will be positive, and then x to the power negative 2. Then of course we can write this nicely in a way that it will end up looking like the hyperbolic sec squared of 1 minus 1 over x divided by x squared. And then that's supposed to be your answer there. And then of course we can solve a lot of problems here. Another problem could be this one that I'm about to write here. So now we have y, which equals to e to the power hyperbolic cos of 3x, which is just going to be dy dx will just be equals to since we can see that e is a number, so this means this is just an exponential function. So we know that when we differentiate an exponential function, we just copy it as it is. So this is just going to be hyperbolic cos of 3x multiplied by the derivative of the exponent of cos is going to be the derivative of hyperbolic cos, which will be hyperbolic sine of 3x. Then we again multiply by the derivative of the argument, which is just gonna be 3 for this case. And then one can argue and say, I want to write this nicely, and then when you decide to write this nicely, it should look like something like what I wrote here, hyperbolic cos of 3x, and then ta-da, that should be your answer for that one. And then now, guys, don't forget to pause the video so that you can work out on this problem on your own and then resume later to check the memo, of course. So when we now have hyperbolic x, which equals to natural log of hyperbolic tan of theta over 2, as well as y, which equals to natural log of hyperbolic cosec theta minus hyperbolic cot of theta. So we can see that we're given two equations with respect to that parameter theta. So we're given a parametric equation. We're given parametric equations here. We should find the y, the x. So meaning we should differentiate x and y separately with respect to theta. So if we start with x, then of course the x, the theta will then be, for the derivative of the natural log, we always copy the argument on our denominator, which is just going to be the hyperbolic tan of theta over 2. And then on our numerator, we're going to differentiate that argument, which is just going to be 1 over 2 multiplied by the derivative of hyperbolic tan. This is just hyperbolic sec squared of theta over 2. And then yes, we can simplify further here, guys. We can simplify further. This is going to be the x, the theta, 1 over 2 multiplied by 1 over what? So sec is the hyperbolic, is the reciprocal of what? Of cos, right? So this is going to be hyperbolic cos squared of theta over 2, just like that. All of this was divided by hyperbolic tan, so we can also change that hyperbolic tan to become hyperbolic sine of theta over 2 divided by hyperbolic cos of theta over 2. And then we can see that if we change this division sign, it will change that if we change this division sign to become the multiplication sign, then we'll end up having this denominator of hyperbolic cos as being the numerator, and this denominator of hyperbolic sine being the denominator thereafter. So at the end of the day, we will then see that one cos here will chop one hyperbolic cos there, and then this will end up looking like the x, the theta will just be will just be 1 over 2, and then we'll be left with 1 hyperbolic cos of theta over 2, and then sine will still be there, hyperbolic sine of theta over 2. And then here, from here, we can change this hyperbolic sign. So then the theta will then be 1 over what? 1 over, this is a double angle, so this is the double angle of sine, hyperbolic sine. So this is the double angle of hyperbolic sine of theta. and then we can just write the reciprocal of this is just going to be cosec, hyperbolic cosec of theta. Of course, we should also find dy d theta, right? So my dy d theta will be simple as well. Because of I'm differentiating a natural log there, I just copy the argument, which is cosec of hyperbolic cosec of theta minus hyperbolic cot of theta, and then we then differentiate the argument. So when we differentiate the hyperbolic cosec of theta, this will become negative hyperbolic cosec of theta cot hyperbolic cot of theta minus what? Minus hyperbolic. So we then differentiate the hyperbolic cot of theta. So when we differentiate the hyperbolic cot of theta, it becomes negative cosec squared. So that negative will multiply with that negative to form a positive. So this is going to be negative, a positive hyperbolic cosec squared of theta. So we can see that if ever we take out the common factor of positive hyperbolic cosec of theta as my common denominator on my numerator, then I will end up getting that dy d theta is hyperbolic cosec of theta as the common factor taken there. It will then be multiplied by hyperbolic cosec of theta minus cot of hyperbolic cot of theta, and then all of this will then be divided by what? By what we had there before. So I'll just copy it, hyperbolic cosec of theta minus hyperbolic cot of theta, and then we can see that this bracket and that denominator will cancel out. So at the end of the day, I will end up having hyperbolic cosec of theta as my dy d theta. So we were told to look for dy dx. We will just substitute into this formula of dy d theta all divided by dx d theta, just like that. And then we substitute. We now have dy d theta and dx d theta. We just substitute there, which is just hyperbolic cosec of theta divided by hyperbolic cosec of theta. Then this gives you your 1. And then ta-da! This should be your answer. Nothing more. Alright guys, thanks for understanding. Now let's see if we can chop this following one. Of course we can, right? Why won't we? Alright, so we are given this equation 3y squared plus x hyperbolic tan cube of y plus 3x squared, which equals to 4. So because of we can't be able to make y subject to the formula here, then we are going to use implicit differentiation to differentiate that given equation. But we should always remember that in implicit differentiation, whenever we differentiate y, we should multiply that derivative by y prime or dy dx, whichever you prefer. So this is just going to be the derivative of 3y squared will just be 6y multiplied by y prime because of I differentiated y, then plus now I have x which multiplies that term. Then I'm supposed to use product rule for me to be able to get the derivative of the two. So when I differentiate x, it becomes 1. I then copy hyperbolic tan cube of y, and then I say plus I copy x, and then I differentiate hyperbolic tan cube. It will be 3 hyperbolic tan squared of y. Then I differentiate the argument. Of course, that's going to be y prime, and then plus, oh, before that I have to know that that tan, hyperbolic tan, is the same as hyperbolic tan of y cubed. So we started by differentiating these outer brackets to get hyperbolic 3 hyperbolic tan squared of y. So we should get inside and differentiate tan again. So when we differentiate hyperbolic tan, we then get what? We then get that this is hyperbolic sec squared of y, and then we differentiate the argument y, which is just going to be y prime, and then plus what? Plus the derivative of 3x squared is just going to be 6x, right? Plus 6x, which equals the derivative of 4, which is 0. Then here we group out factors that consist of y prime to be on our left, and factors that doesn't consist of y prime, they will be on our right. So 6y, y prime will be left here, and then plus 3x y prime hyperbolic tan squared of y multiplied by hyperbolic sec squared of y will then be equals to negative 6x minus hyperbolic tan cube of y. We then take out the common factor of y prime. We will be left with 6y plus 3x hyperbolic tan squared of y multiplied by hyperbolic sec squared of y, which equals to negative 6x minus hyperbolic tan cube of y. And then we just divide both sides, of course, by this left hand side bracket to end up solving for y prime. So we'll end up getting negative 6x minus hyperbolic tan cube of y, all divided by what? All divided by 6y plus 3x hyperbolic tan square of y multiplied by sec squared of y, like this. And then yeah, ta-da, this should be your answer. Guys. Yeah, so yeah, we should arrive to something like that as our answer. And then now let's see what else we can do. The other thing we can do is just this. Okay, we now have y equals to hyperbolic sine of hyperbolic cos of x. So this should be easy, right? So dy dx will just be hyperbolic sine of that. When we differentiate hyperbolic sine, it just becomes hyperbolic cos. So this is just going to be hyperbolic cos of x, just like that. And then we shouldn't forget to multiply by the derivative of the argument. So the argument for that case is hyperbolic cos. So when we differentiate hyperbolic cos, it just becomes hyperbolic sine of x. And then ta-da, you have your final answer. That was one of the easiest. And then we now have y which equals to the hyperbolic chord of root of 1 plus x squared. So when we differentiate this, guys, don't forget to pause the video so that you can work out on these problems on your own and then resume later to check the memo, of course. So y, when we differentiate it, it will just be dy the x, which equals to the derivative of hyperbolic chord. It is negative hyperbolic cos x squared. So this is going to be negative hyperbolic cos x squared of root of 1 plus x squared. Then we shouldn't forget to multiply it by the derivative of the argument being a root of 1 plus x squared. So to derivate the root, guys, I've done that before. I've explained how you can cram it. I've said that you just put a fraction on your denominator. You say 2 root of 1 plus x squared, just like that. And then of course on a numerator you are supposed to differentiate your whatever that's inside the root there. So that's just going to be derivative of 1 plus x squared is just 2x, and then 2 and 2 will cancel out, and then at the end of the day you will end up getting that you have minus x multiplied by hyperbolic cos x squared of root of 1 plus x squared divided by a root of 1 plus x squared. And then tada, you now have your final answer, which is that one. Yeah, that was an easy one. Of course, that was an easy one. All right, we have the following one here, which is y equals to natural log of hyperbolic chord of 2x. So this should be easy as well. Feel free to pause the video so that you can work out on this problem and then resume later to check the memo. Of course, that's a very good way of learning. And then this is going to be what? So since we are differentiating a natural log there, we should just know that we're gonna put a fraction, and then on our denominator we just copy the argument that is given to us. So we are given hyperbolic chord of 2x there, and then on my numerator I'm supposed to differentiate that argument. So this is going to be the derivative of hyperbolic chord. It's negative cos x squared, right? Negative cos x squared, negative hyperbolic cos x squared, hyperbolic cos x squared, this is CSCH squared 2x, and then multiplied by 2, of course. But then we can simplify this, right? We can simplify this. So this is dy dx will then be equals to negative. We can change hyperbolic cos x squared to become we can change it to its reciprocal, which is going to be 1 over hyperbolic sine squared of 2x multiplied by that 2 which was there, and then divided by the hyperbolic chord. We can change to its reciprocal as well. Yeah, so that's going to be hyperbolic cos of 2x divided by hyperbolic sine of 2x. And then if we happen to change this division sign to become the multiplication sign, then of course we'll have to then make this denominator to be the numerator, and the numerator becomes the denominator, like that. So at the end of the day you're gonna have something like -2. Okay, and then after you have changed your division sign into a multiplication sign, you'll realize that one hyperbolic sign will chop one hyperbolic sign there, so you will end up being left with just one hyperbolic sign which multiplies the hyperbolic cos of 2x. And then we can see that we can simplify further here, but we just need to change this to a double angle of hyperbolic sign. So without changing the equation, we can just multiply it by 1 over 2 by 2, which is the same. 1 over 2 multiplied by 2 is 1, so meaning we didn't change the equation, but we can make use of 2 hyperbolic sine of 2x multiplied by cos of hyperbolic cos of 2x, of course. So we can change this to become the double angle, and then of course minus 2 divided by half, that's going to be minus 4. So dy dx will then be minus 4 divided by hyperbolic sine of 4x, right? But then 1 over hyperbolic sine, it's a reciprocal, so we can change that to negative 4 what? Hyperbolic cosec of 4x, and then that should be your answer. So yeah, I hope you got it, you understand it as well. So yeah, nothing tricky there, guys. It's just you applying maths. Alright guys, now we have y which equals to x to the power hyperbolic cos of x. So we are required to find dy dx in this equation. So we can see that we have a function to the power function on our right hand side there. So for us to simplify this, we just need to know that we can introduce logarithms on both sides. So this is just going to be the natural log of y equals to the natural log of x to the power hyperbolic cos of x. And then we apply laws of logarithms there, or properties of logarithms. This is just gonna be the logarithmic natural log of y, which equals to the hyperbolic cos of x, hyperbolic cos of x multiplied by the natural log of x. And then on our right hand side, we can see that we've got two different functions multiplying each other. That means for us to be able to differentiate that, we should use product rule. But then another thing is that we need to use implicit differentiation here, because if we can, but it's gonna take us back. So for the sake of not going back, we should just differentiate it implicitly. So this is just going to be y prime upon y, which equals to the derivative of hyperbolic cos is going to be hyperbolic sine of x multiplied by the natural log of x, and then plus, because of we're using product rule, then you now copy hyperbolic cos of x. You copy hyperbolic cos of x, you differentiate natural log of x. We know that we copy the argument, we differentiate the argument on top, so the derivative of x will just become 1. So we are required to find y prime, right? So we need to cross multiply to end up having y prime as the subject of the formula. So, or subject of the equation, whatever that may be. So this is going to be y prime, which equals to y multiplied by the hyperbolic sine of x multiplied by the derivative, multiplied by the natural log of x, and then plus hyperbolic cos of x divided by x. And then we know what y was, so we can just say y prime equals to x to the power hyperbolic cos of x multiplied by, I'm just going to copy that, which is just going to be the hyperbolic sine of x, of course, multiplied by the natural log of x plus hyperbolic cos of x divided by x, and then tada, you reached your final answer. So I hope you got it and you understand it, guys. That was it. So let's see if we can solve something else here. All right, for our last question, we now have a hyperbolic sine of xy, which equals to e to the power x multiplied by y, of course. So we should find dy dx in this given equation. So what we are going to do first is that we're going to differentiate hyperbolic sine, of course. That's going to be hyperbolic cos of xy. Then we shouldn't forget to multiply by the derivative of the argument there, which is going to be the derivative of xy. And since it's xy, we should use product rule, but implicitly so, because of we cannot be able to make y subject of the formula in this equation, right? So we should know that when we differentiate y, we should multiply that derivative by y prime. So let's start and differentiate xy implicitly. So this is just going to be x. Oh, when we differentiate x, I mean it's just gonna be 1, then we copy y, and then we say plus because of we're using product rule, then we say plus x, and then we differentiate y, is just gonna become 1, but because of we differentiated y, we have to multiply by y prime or dy dx, whichever you prefer, guys. It's the same thing. And then now on our right hand side, we have y multiplied by e to the power x. So we're going to differentiate this using product rule, of course, but we shouldn't forget that whenever we differentiate y, we should multiply that derivative by y prime. So when we differentiate y, this is going to be 1, but because of we differentiated y, it will become y prime, then we copy e to the power x. We continue with our product rule. This is going to be plus. Now we copy y, we differentiate e to the power x, it remains as e to the power x. And then from here we can just multiply throughout to eliminate this bracket. So this factor of hyperbolic cos of xy will multiply y plus xy prime there. So this is going to be y hyperbolic cos of xy plus xy prime multiplied by hyperbolic cos of xy, which is then equals to y prime e to the power x plus y e to the power x. So in the following step, we just need to group factors that consist of y prime to be on our left, and then everything that doesn't consist of y prime, we're going to take it to the right, and then we'll end up having xy prime here, hyperbolic cos of xy, hyperbolic cos of xy, hyperbolic cos of xy minus y prime e to the power x equals to y e to the power x minus hyperbolic minus y hyperbolic cos of xy. Then on our left hand side, we're just going to factor out y prime as our common factor there. So if we take out y prime as the common factor, we'll be left with x hyperbolic cos of xy minus e to the power x, which then equals to, so we'll again take out y as the common factor on our right hand side. We'll be left with e to the power x minus what? Hyperbolic cos of xy, right? And then since we're looking for y prime, we just need to divide both sides by the left hand side bracket there. So this is going to be y prime, so we're going to divide both sides by this bracket that's on our left. So this is going to be y e to the power x minus hyperbolic cos of xy, all divided by what? All divided by x hyperbolic cos of xy minus e to the power x, and then ta-da, you reach to your final answer there. So yeah, that was it guys. Thank you for watching. I'll catch you on the next video.